Yeah, thank you very much for this opportunity for me to provide me this kind of opportunity to discuss something about water resource management using GIS technology. For myself, I'm Dr. Asib Ahmed, working as an associate professor in the Department of Geography and Environment, University of Dhaka, Bangladesh. So on this discussion, what I need to cover today, because the time is very limited today, that would be the distribution of water surfaces on Earth, and then the water resources, why we call this resource, and then water resource management issues and the challenges in water resource management, and finally, the main thing is the use of GIS in water resource management. So we all know this kind of basic things, but this is a bit reminder to you that on the Earth's surface, we have 71%, around 71% water, and we have 29% land. And on this Earth's surface, the water contains approximately 1.4 billion square kilometer of water. That covers around 97% water that is in the oceans. And if you think about the mass, it contains about 1.4 into 10 to the power 18 tons of mass, the water, and the total volume of water on Earth, that could be around 1,386 million square kilometer of volume of water on Earth. That the area that would cover on this Earth surface is 361 million square kilometer of area will be covered by the water. And the average salinity, if you think about the salinity of water, because this is very important to water resource management, salinity of Earth's ocean, that could be 35 gram per kg of seawater, that is 3.5% of any volume of water, and that is the average salinity of water. So on Earth's surface, if we think about the water as a resource, then we have to think about the total distribution of water on Earth's surface. And if you think about the distribution, then the ocean water that I have already mentioned that contain about 97.2% ocean water. Then the glaciers that contain about 2.1% of water. That is also very tough to reach, or that is very tough to make it usable. And then the groundwater, that is 0.61% on an average groundwater is available. And then what we have left, that are freshwater lakes, inland seas, soil moisture, atmosphere, and rivers. And in this on these 5 issues, say like freshwater lakes, inland seas, soil moisture, atmosphere, and rivers, this contain very less percentage of water compared to the total volume of water, or compared to the ocean and glacier and groundwater. And that's why, for example, for ocean water, we cannot use it directly. That is 97.2% of water, we cannot use it directly. And then glacier and other ice forms in different top of the mountains, 2.1%. That is also very difficult to make it usable. Then groundwater as well. So the remaining things are the freshwater, inland seas, soil moisture, atmosphere, and rivers. These are in some way usable, especially the rivers or the inland seas or in soil moisture and the groundwater as well. But these portions are very less in percentage. That's why the usable water is very less, and that's why the water that we think for use is a resource for us, because if it is become a resource, then that one criteria could be the non-abundance thing, and water is non-abundance in respect of using the or the availability of water to use. That's why we can call it as a resource. So water resource that we say that can be usable, can be as a resource, that is very less amount, that is 0.023% of water. And water accounts for a mere 0.23% of the total Earth's total mass of water. So from that, we can also use a very small percentage, about 0.3% is even usable by humans, and other 99.7% is in the ocean, soil, ice caps, and floating in the atmosphere. So that's why we can call it a resource. And if you just look at this picture, if it is the total mass of the Earth, then the hydrosphere, so like it's a comparative illustration. And then if you think about the freshwater, that is not all these are usable. Freshwater, that is 2.5% of the hydrosphere. So if you think about, look at this picture, then our freshwater is very limited, and that is why we can compare it like this way. That's why we can call it a resource. So freshwater distribution, that I have already mentioned in the previous slide, that in this distribution, so what we can use, what type of in what form we can use this kind of resources. So mainly for rivers or for the groundwater, we can extract it, or we can make it as usable one. That's why the usable one is also very less amount. But for soil moisture, 3.8% of the usable water, we cannot use it directly. But for surface water, we can use it directly. But for atmosphere, 3% of the usable one, we cannot use it directly. So in these lakes, for example, 20.9% we can use it directly. So most of this fresh water, we cannot use this kind of portions, but we can use very less amount of portion. For example, 25 to 26% of usable water or fresh water we can use only. So from that context, for the usability, we can also say that freshwater is a resource. So now come to the water resource management, because this is a very scarce resource, and we are polluting this kind of resource. We are contaminating this kind of water in an increasing rate. That's why we need to think about the management. That's why the term water resource management, or WRM, is a very important one for us. And that's why we need to manage in a sustainable way. And water resource management is such kind of process of what? Process of planning, process of developing and managing water resources. For example, we need to plan how we can manage this kind of water resource. We need to think or find out the ways how we can increase this kind of water resource from the usable sources, and then how we can just distribute or we can consume this kind of water resource. So all these things will be included in the process. So water resource management is the process of planning, development, and managing water resources in terms of both water quantity and quality as well, because we cannot use the polluted water. So we have to ensure the quality as well. So we talked more about the quantity, but quality is also another factor that we need to think when we deal with the water resource management. And this issue is not only for some areas in the world. This issue is a worldwide or global issue that we need to deal about, and that's why across the world we need to think about this kind of thing, and all types of how we can extract this kind of water from all types of available sources. We need to think for all water uses, and it includes the institutions as well. That means how and what institutions or which government or NGOs or non-governmental organizations can manage this kind of water resource. So we need to think about the institutions as well. We need to think about the infrastructure, and this is very important. That if you have a lot of water body, but we don't have any infrastructural facilities, how we can extract and how we can process and how we can distribute, then that will not be a sustainable use. And then we need to think about the incentives and information systems as well, that how we can distribute this kind of system, which area are scarce and which area are not. We need to think, we need to be informed previously that how we can distribute this kind of system. What areas are scarce or what areas are water stressed area, we need to identify. And that's why that support and guide water management. So water resource management is a holistic approach. In this approach, you have management, you have institutions, you have infrastructure, you have technology and everything. So that's why in water resource management, technological innovations or technological support is a very vital one. So for example, some challenges that we face in water resource management when we are dealing with water resources, we face some challenges, and these are some examples of the challenges according to say like water World Bank estimates. In 2007, 40% of the world population live in water scarce. That is a very alarming one. 40% people, world population in water scarce areas, living in water scarce areas, and approximately 1/4 of the world's GDP is exposed to this challenge. This is also very alarming. The second example of the challenge is by 2025, about 1.8 billion people will be living in regions and countries with absolute water scarcity. So 1.8 billion people is a very big amount. And with current practice, if you think about the current practice, the world will face a 40% shortfall between forecast demand and available supply of water by 2030. So this is another challenge for water resource management. So including all these things, we also have some added challenges. For example, chronic water scarcity, hydrological uncertainty, extreme weather events, for example, floods and droughts, are perceived as some of the biggest threats to global prosperity and stability. These challenges, these added challenges also will be very vital for future water resource management. So that's why data and information system that I told you earlier, that data and information systems are very needed thing for integrated water resource management. So why integrated? Because all the actors, all the aspects are relevant, all the management aspects, all the demographic aspects, all the technological aspects are related with water resource management. That's why we need an integrated water resource management scheme in water resource monitoring systems, for example, in decision making under uncertainty situations, in system analysis, in hydrometeorological forecast and warning as well. So all these issues, for example, water resource monitoring issues, for decision making issues, system analysis issues, and forecast and warning issues. So we need an integrated water resource management scheme that is well-known concept, and that is the agreed concept by the experts from different communities. So that's why we need, considering these challenges, we need an integrated water resource management schemes. And for this integration, what we need an integrated system, and that would be very much effective for water resource management. And GIS in this aspect, we can call this system information system as an integrated system that can hold a lot of things together and can give you a decision support system to you. That's why you can say GIS as an integrated system that you can use in water resource management. So that's why the importance of GIS in water resource management is very vital and is very crucial. And if you think about managing this kind of water resources, then you need to think about data. And what type of data? You need a hydro data. That means hydro geodatabase you need to create. And GIS is a platform that can provide you that kind of hydro for making hydro geodatabase. And for hydro geodatabase, you can include a lot of things in that geodatabase. So basically, if you don't have any database, then you cannot assess, you cannot analyze, you cannot predict, you cannot forecast, and you cannot deliver any decisions to the community, those who are suffering from water scarcity. So that's why you need to create a database first. And this database can be, for example, on water quality analysis, watershed management, flood management, groundwater modeling. So these are some examples of hydro geodatabase. For example, water quality analysis, what you can include in this assessment. So you can include water quality modeling. You can perform some modeling works on water quality analysis. You can use GPS or photographic tick points or tie points. You can use passive and active water quality monitoring systems in this water quality analysis. For example, the next can be say like watershed management. You can perform terrain modeling by using GIS. You can perform flow modeling. You can perform debris flow probability. You can perform stream order analysis. These are basically the works that can help in managing water resources. For example, if you think about the stream order analysis, that can also be a part of water resource management analysis, or we can contribute by performing stream order analysis. You can contribute to the water resource management. Then you can identify what amount of water can be available from these kind of streams, and what are the orders, and what volume, what proportion of water can be collected from these kind of streams. So that can be an example. Say like a stream order analysis can be an example of performing some assessment that can help in managing water resources in a regional scale. So next one can be, say, like flood management. Flood management can also impact on water resources, and that can be said like you can perform a lot of things on flood management. If you manage flood, and then you can have different types of possibilities or the probability of managing your water resources. For example, you can make floodplain delineation maps or floodplain delineation areas. You can assess the channel characteristics. You can assess the inundation modeling. You can perform inundation modeling. You can identify or analyze the infrastructures or the households that can be affected by the flood. You can perform any risk modeling and mitigation analysis by doing by developing this kind of hydro-geo database. So, for example, groundwater modeling as well. We normally extract groundwater model that we have shown that groundwater is also a very big amount of available water or the freshwater sources. So groundwater modeling is also very crucial, and groundwater extraction is a very alarming issue right now in the world. So that's why what amount of water you have, you can assess in GIS. What amount of water you can extract, you can also assess by performing GIS model. So modeling subsurface flow rate, advection, concentrations, you can use GIS, and modeling oil and spring models you can also run for groundwater modeling. So all these things can give you a strong hydro-geo database, and if you have this kind of hydro-geo database, then you can perform, you can implement this kind of data. You can for decision making of water resource in decision making water resource management. So that's why you need to build a geodatabase, and you need to perform some assessments, some modeling or analysis by using GIS in a different ways. So these are the summaries of how you can use GIS in water resource management. And for individual topic, you can have a lot of resources in internet or in secondary, as a secondary data. You can go through this kind of things, how we can perform a terrain modeling, or how we can perform stream order analysis by using GIS technology. I think SuperMap also have this kind of facilities. You can go through that, the documents or the secondary literature, how we can use SuperMap GIS on these issues. Okay, so these are some a bit different use of modern use of GIS in water resource management, because if you think about the management in an urbanized area or in a controlled area, then you can have a system there, and that's why you need to just take this kind of issues in a systematic order. You need to perform a systematic distribution of water resources into the people, those who are consuming this kind of water. That's why you can have a strong database. You must have to have a strong database, otherwise the total system can be disrupted. That's why GIS can give you a three-dimensional view of how you can distribute your networks or the pipeline networks to the community or to the users, and that's why you need to use GIS. And for say like these are some examples of how we can use GIS in distribution or managing water supply to the people or community. For example, you can assess the pollution analysis. That means in which areas are conflicting, which areas you cannot just go beyond these areas, or which areas you have to pass through the pipelines to the water, to the community, to the water of the water. That's why You can perform collision analysis. You can assess the profile checking in GIS. You can identify the burst simulation. For example, you can simulate which areas can be which pipeline areas can be busted in future or in near future. So this analysis can also be possible, and you can identify the pipeline distribution. You can identify the shortest route reach. You can also identify how you can your pipeline can be reached within a, say, like a shortest distance by following shortest distance. You can have, say, like pipeline excavation. So which areas can be excavated and which areas can be need to be maintained in future. You can also identify this kind of things. So all these things are are some examples of how you can manage water resources in an urban area or in distribution area, for example. So these are the things that the GIS can give you an opportunity to perform for a very good water resource management in a sustainable way, in a sustainable manner, both qualitative way and both quantitative way. So the application mechanism, if you think about the mechanism, then we can say if you have, say, this is a very generalized application mechanism of water resources, how we can use GIS in water resource management applications. For example, if you have some vector data model or shapes, you can have raster models or satellite images, you can have georeference tabular data. All this data can be, say, like overlaid in layers and allowing the visualization that will be very good for visualization. And then you can identify the data in qualitative and quantitative hierarchy can perform here. Specialized visualization also can be performed here. And then the analysis from this kind of overlaid and qualitative and quantitative information, and then the specialized visualization, that all can be included into the analysis of information or interpretation and spatial correlation of different types of phenomenon. For example, economic, political, social, and environmental phenomenon can be also assessed in this area. So this is the very general one that GIS can be used in application mechanisms of water resource management. And then the analysis can be the elaboration of diagnosis can be come out from this kind of analysis, and that can also help in planning strategies and decision making processes for water resource management. So this is a very generic one, and you can use GIS in like this way, or you can use GIS in different ways, case by case. So this is not the same size fits all system. So you have to think different systems. You have to design different systems for different applications. So GIS, this is an example that GIS can use like this way as well. So for example, GIS hydro modeling, you can use it in a different way. For example, in capital improvement plan, watershed utility, flow analysis, water quality, future growth of the distribution system. You can map capital assets. So all these things can be included in hydro modeling, and that it efficiently parameterized into input data of various hydrological and water quality models to present spatial and temporal characteristics or the factors that can affect hydrological components. Hydrological components, for example, surface, subsurface, groundwater, etc. This kind of from this kind of areas, for example, surface areas component, subsurface, and groundwater components can be included, and the pollutant generations or non-pollutant sources can be identified, and then how this can be transported via surface and infiltration, and thus that to the final to the stream. So this kind of hydro modeling can also be performed by using GIS technology. So this is an overview of using GIS in water resource management. So thank you. If you have any questions, and then we can discuss. Thank you very much.